This is the wall avoiding robot code that I came up with. I used like little bits from here and there, but mainly I made this all by myself. The first line, I included a server library, which is needed because this robot is using a server robot motor to be able to sense stuff. I assigned all the motor wires to different pins, so the right pins forward and backwards are at 4 and 5, and then left forward and left backwards at 2 and 3, and then my trigger is at 8, and then my echoes at 9. I made this dangerous threshold at 20 centimeters. So at 20 centimeters, it will stop and we'll look around and do that. I associated the servo motor with pan motor, so that means it will pan forward and backwards and such. The duration long, like how long it will take, is equal to duration. This is set up all of my motor pins or outputs, right forward, right backwards, left forward, left backwards. So that means the signal is going out to them, not it receiving information going into the Arduino. So yeah. I attach the pan motor to pin 6, and then at normal it'll be at 90 degrees. 90 stands for what integer at degrees it will be at. Now for the whole setup, at the void loop, void loop, it would send out a ping if this distance forward is greater than the danger threshold, which is at 20 centimeters. Both of the left forward and right forward pins will activate by going high. High means it's going on, turning on. Else, if the path is blocked, both of the pins will turn off. Both of the motors will turn off by going on to low. Then the motor will pan to 0 degrees, and then it'll stop for half a second. Then it'll send out a signal, then wait for half a second, and then it'll pan the motor for 180 seconds. And then while the program will delay for 700 seconds. 700 microseconds, which is a seventh of a second. And then it will send out a signal, and then it will delay 500 seconds, and then it will pan back to, not 500 seconds, it will pan over 500 microseconds. Okay, and then it will compare the distance between left or right, and then if the left distance is greater than the right distance, the right forward pin will go on high and the left backwards pin will go on high. So that means it'll go forward on its right side and the back. On the left side, the wheel will go backwards, and then delay that for 100 seconds. No, not 100 seconds, 100 microseconds. Then both of them will turn off and then delay a tenth of a second, tenth of a second. Else, if the right distance is greater than left distance, then right backwards pin will go high, and left forwards pin will go high, and then it'll go delay that for a tenth of a second, and then both of them go low, and then delay a tenth of a second, and then after all of this, it will go through the loop again. So both of the pins will activate and go forward, and then until it detects an object, and then it will go through the loop again. If both of them are equally obstructed, I have it so that it will turn like practically 180 degrees, which I made it by making the motors go at a fifth of a second, on for a fifth of a second, then both turn off. So, and then this is the code for my sensor. So the pin mode trig pin is output, and then echo pin is input. That means any information coming in will go through the echo pin, and then when trigger pin is low, it delay for 2 microseconds, and then it go on high, and then it delay for 10 microseconds, then go low, and then go for, and then it'll keep going on and on through that. Okay, and then pulse in, high, return distance. That's the formula for, it's a duration, which is the time it takes back, divided by 29, divided by 2. So this is basically I borrowed this code. I found this code somewhere else. It used many times, and I thought it was useful. And then it seems to work out for this robot, so it works. This is basically the code of the robot. You can find it on my document, and then I'll probably send a link of it below the video.